Okay, let's talk about Monte Carlo Dropout. This is one of the most exciting parts of the course, as we're going to be using it directly in the next programming assignment, which is the final course project. So it was introduced in a 2016 paper, and it gives actually an outline between dropout, which is an intuitive method, and also approximate Bayesian inference, which gives it a mathematical motivation. And in the same paper, they introduce MC dropout, or Monte Carlo dropout, which gives a measure of the model's uncertainty, which is extremely useful in risk-sensitive applications. Okay, how do we implement Monte Carlo dropout? Quite simple as well. We can do it in 4 lines. So this keras.backend learning phase scope 1. What we're doing here is we're forcing training mode, or we're forcing dropout on, meaning that when we do this prediction here, we actually make predictions on 100 different neural networks in theory, because with dropout, you're effectively changing the neural network at each instance. So here we're making predictions on 100 different neural networks, basically. And then we've made predictions on 100 different neural networks, and now we use this method. And what this does is we take the average of all the predictions, and that's the final prediction. So we must first turn training mode on, which in turn turns dropout on within this with block here. Next, we make 100 predictions over the test set, and we stack them into yprobas. The predictions are all going to be different. In theory, some might be the same, but mostly they're going to be different because we have dropout on, which means there's going to be different artificial neural networks making the predictions. If you want to use Monte Carlo dropout in conjunction with other special layers such as batch normalization, you shouldn't force training mode on as we did just now. Instead, we need to create this custom Monte Carlo dropout class to replace the dropout layers. Let's see how we can implement this. So it's quite simple. This is a very important slide, but what we do is we create this class here, and this is going to be basically put in the exact place as where we were putting dropout before. So before we did the input layer and then a dropout, hidden layer, dropout, etc. But now we do input layer, Monte Carlo dropout, hidden layer, Monte Carlo dropout, and we input the dropout rate just as before. So this is an important quiz because you'll be using this directly right now in the programming assignment. But write down on a piece of paper the code to implement the class MC dropout, just as on the previous slide. See if you can cover it with your hand or something, and then remember it and also understand it at the same time. I'll give you a minute I'll give you a second to pause now so you can complete that. And here's the solution. I'll see you in the next and final lecture.